Good morning.
Good morning, sir.
Good morning,
Morning.
sir.
Good morning, sir.
Any doubt from the last class? तुम लोग पढ़ रहे हो कि नहीं? मतलब जो पढ़ा रहा हूँ वो कभी देखते हो या है?
सर आप लाइक 5
देखते
तक
हैं
भेज
सर।
चुके थे नोट्स, उसके बाद का सर अपलोड नहीं किया सर।
तो तुम लोग पूछे भी नहीं, मुझे लगता है तुम लोगों की जरूरत भी नहीं है।
नहीं सर, आप जो क्लास में पढ़ाते हो तो मतलब ऐसा पढ़ाते कि याद हो जाता है, तो इसलिए ऐसे पूछे नहीं, लेकिन आप अगर चाहेंगे तो सर अपडेट कर दीजिए।
नहीं, मेरे कहना ये है कि कभी कभी ऐसा लगता है कि सीख गया हूँ और we will not forget. That is not true. And there are many things. Sometimes it comes to your mind that you have understood everything, but when you go and solve problems, then you will face difficulties. Okay, so you need to
Yes.
practice. When you practice, then only you will have doubt, and then only you will go further forward and deeper into the subject. Okay, it is not that it's a tradition in some institutes here also. It's a tradition that whatever teacher is teaching, the questions will come alike, and it's not like that. This is something which is be useful throughout your life, and this is an introduction, only introduction to a huge, complicated, and interesting subject. Okay, so please pay attention. Okay, let's begin today's class. Uh, Today we will discuss yesterday we have discussed this, right, by a path generation problem. Okay, so in path generation problem, as we said that there were and all the problems we are solving here, 3 position synthesis problems. So 3 positions will be given, and from those 3 positions or 3 in motion generation there are 3 3 position of the coupler given, and we had to find out the dimensions of the links, or basically the distance between hinge points. In the path generation problem, one point on the coupler has to move through a path. So for that we have found this. Okay, and in the next step, the third problem is function generation problem. So today we will discuss that function generation problem. Okay. So we start here. This is our lecture number 9, and today is, tomorrow I will not take the class, but the lab class will be there. Okay, so why people are waiting in the lobby? I have allowed everyone to enter into the classroom. Yeah. So we are discussing function generation. Function generation problems. Okay. In function generation, we have discussed that the actually the suppose the motion of the output link, let's say y, the motion of the output link is equals to, this is a function of motion of the input link. Okay, or if this y is just angles, can happen this y are just angles, then these are also angles. So we take one example for this kind of problem, and these are some issues with this software. Let us not even write here because we need some space, and so the example we are taking here, the two specified pairs of coordinated movements to two specified pairs of coordinated movements of input and output links be generated. Movements of input and output links be generated. That is the problem. Two specified pairs of coordinated movements of input and output links be generated. What are these coordinated movements? What are these coordinated movements? Coordinated movements are theta 2, 1, 2, theta 4, 1, 2, and theta 2, 2, 3, theta 4, 2, 3. So what does it mean? It means, let us draw something here. So I'll draw a small figure here. Suppose this is the position of a crank, and then this crank is rotated by an angle. Let's say it is rotated by an angle 45 degree. Just remember, I will forget. So this crank is rotated by an angle 45 degree. It came to this position, and then it is rotated by angle 30 degree, and it goes to this position. Okay. So what we are saying here is it has started from this position. This is position 1, this is position 2, and this is position 3. Okay. And this is the point. This is the point which we'll call the this is the point which we'll call the point O O2. This is our O2 point. Okay, let us write it. This is O2. And the crank, this is the movement of the crank. This crank is moving from this position, from this position to this position and this position. So the angle between these two position, this angle, we'll call it theta 2, 1, 2, and the angle covered during this motion. We'll call it theta 2 to 3. 1 2 means from position 1 to 2, 2 3 means from position 2 to 3. This is the motion of the crank. Now, for the same uh, mechanism, suppose the follower is somewhere, let us take it somewhere here. Okay, the follower is here. So first we will draw the follower base point, that is O4. So this is point O4. Let us write it. This point is O4. Okay. So if we make some hinge here, this is one hinge point and this is another hinge point. Okay. The problem we are solving is a function generation problem. First, we are trying to understand what is a function generation problem. So as the uh, problem statement is saying that there are two specified pairs of coordinated movement of input and output link, and we have written here the coordinated movements are, this is one pair theta 2 theta 4, one pair, and another pair is there. Okay, so suppose the link 4 look like this. At first it is here, suppose this is link 4, this one is link 4. Let us write it. What should I write? So we can write link 4. Okay, this is link 4, it is here. And according to this specified movement, for example, you can take example this theta 2 1 2, as we said here, it is how much we have taken, 45 degree, right? And
Yes, sir.
theta 4 for that 1 2 is, suppose it is requirement that that's theta 4 1 2 is say 20 degree. Okay, so this is one pair of coordinated movement. Okay, that is theta 2 1 2, theta 4 1 4. That is one pair. Now another pair of coordinated movement is theta 2 2 to 3. For that movement of crank, what is the movement of follower? So that goes from, sorry, this should be theta 1 to 2, and this is theta 2 to 3. So this is theta 2 2 3, theta 4 2 3, and for example theta 2 1 2, I think we have taken 30 degree, right? And suppose it is required, somebody asked you there that
Sir, theta 2 3, sir.
2 3. Okay, somebody asks you design a mechanism that is a required for me, and you do it like this, that when it for this motion, when you rotate by 45 degree angle, follower should move by this 30 degree, sorry, 20 degree angle, and when from position 2 to position 3, this link 2 rotate by angle 30 degree, then it should rotate by an angle, let's say 15 degree. Okay, so these are the two coordinated movement which are specified by your client, and you have to design the mechanism. Okay, so let us first show where the follower positions are. If this is the position 1 of the follower, with respect to this position 1, we must have position 2 and 3, and these two positions are this. Position 1 is this, position 2 and 3 we have to draw. To do that, we just to copy this and then rotate it by how much we should rotate from position 1 to position 2?
20 degree.
20 degree up. So we have rotated and placed it here. Similarly, for the next pair of coordinated movement, how much we should rotate it?
15 degree.
15 degree.
So we rotate 15 degree. Remember that for our drawing we are doing so, but it will be given. Somebody will ask you that I want a mechanism like that. Please design it for me. Okay, so we go and write down the positions. This is position 2 and this is position 3. Okay, so these three coordinated positions. Now we have to find out where is point A and where is point B, and that's enough for our design, right? When you already O2 and O4 are given, okay, and these three coordinated, two pair of coordinated movement are given. So one pair is theta 2 1 2, theta 4 1 2, and theta 2 2 3, theta 4 2 3. Okay, these pairs are given. Using this motion, we have to find out A and B. So what we will do now is we will assume a location of point A. Now one can ask why you are choosing point A. You can also choose point B. Okay, point A is on the crank. This is linked to. Point A is on the crank. Point B is on the follower. Point A on the crank. Okay, we have chosen a point on the crank. Suppose that point is nothing but this end point. Okay, this point is point A. All right, this point is point A. So we have, let me do something. This is point A. We will call the next point. This is, we will call this A1. This is A2 and A3. Okay, I am removing this because of some issue which may arise. Let me put there a circle. So this is point A. Okay. Similarly, here this is point A2 and point A3 is here. If you want to know about this software, this is a open source software. You can download. This is called IPE. Okay. Only thing, if you want to write something on it, you have to use this text box, and that text box will work when you download and install latex. Okay, some basic latex software you have to download. That is also open source software. If you do that, then you will be then you can use it. Otherwise, you can draw it, no problem. Drawing has no problem. Only thing, when you try to write it using this text box, then you have to use lintex. Without that, it will not perform. And the good thing about this software is, whatever you draw here, that is a vector plot. That means you can zoom it up to any x. There will be no problem of resolution. Okay. So the problem is defined. A1, A2, A3 points are there. Now what is left is, we have to find out where is point B. Okay. Determine position of B on the follower. Okay. We have to determine position of point B on the follower. That is the problem we have to solve. Can somebody tell me how can we solve it? We will use the inverted motion, okay, mechanism, or the method of inverted motion. In this case also we'll use that. Now can you tell me what exactly we should do so that we can solve the problem? Any idea what exactly we should do so that we can solve the problem? Any guess?
The position of O2 with respect to A1 be done. O2.
Position of O2 with respect to A1.
Sir, position of O4 with respect to A1 O2.
Position of O4 with respect to, okay. We'll do it using the, suppose we get the just a minute. Just think about that. If I make this because point A is known to us, we have to locate point B somewhere on this. And suppose I just present the inverted motion of this A1, A2, A3. Okay, we have to locate B, right? Now AB is a fixed distance. Yes or no? AB is a fixed distance or not?
Yes,
Yes,
sir.
sir.
Yes, yes,
Length
sir.
AB.
Yes, sir.
So if we just have make this follower fixed, okay, and with respect to this follower, if we draw the inverted motion of point A1, A2, A3, what we will have? We will have new positions of A1, A2, and A3 with respect to this point 1. Okay, position 1. And then can we do the same thing as, I mean, the B point? Can we find out this B point as the perpendicular bisector? Okay, as the perpendicular bisector of these two, I mean, this A1 and A2, A2 and A3, we will get some inverted positions. And from those two positions, we can have the perpendicular bisector. They will intersect somewhere on B. Okay, and that is the point, hinge point on B. Let us do that, and then you will ask me if you have any doubt. Okay. So that I should do it. We will do this here. Okay. So as we did for our previous cases, we will first copy essential positions. This one, link 4.04. Okay, and then link to, let us copy this 0.02, and okay, what I will do, I will draw another line just to, before I go to this, let us draw a some some line which is which will connect these 2 points O4 and O2. Okay, this is just for understanding that there is a link 1. Okay, now we will copy these links, link 4, O4, link 1, and link to this point A1. Okay, let us copy it and we'll shift it to some suitable point, suitable position here. So that's not a good idea. All right, so I keep it there. Now, what we have initially, this is position 1 of the follower, position 1 of the crank, and we have not copied the this point to, let us copy it and shift it to that point. Okay. Our next step is to get the second position. So we now, what we are now doing is, today I have not pressed the recording option. So can I do that right now? Okay, so we have started first, we have copied the first position. Now we are going to copy the second position. This one, O4, O2, and position to configuration of the mechanism. We now copy it and we will shift this whole thing to here. But one thing we will take care, what is that? We have to merge this follower position with 1. How much we have to rotate the whole thing so that it will merge with this one?
45 degree.
Minus 20.
Degree.
Minus 20.
Minus 30 degrees.
Minus 20 degree. Okay, so now they are exactly matching. The follower position is exactly matching. So let us write down here. This position is A1, right? And next we have, okay, let's not do that. This position is A2. Okay, this one is A2. Now we will copy the third position. So let's select this one, 4, link 1, O2, link to A3. Okay. This you will do using your trace paper. It is easy. For you take a trace paper, which is a transparent one. Have I pressed the copy option? Now we will shift it. We'll shift from this position to this position. How much we have to rotate?
Minus 35.
Minus 35.
Okay. So to just make a difference, or so we'll do that. Now that means what? What is this point? This point is A3. Let us call it A1 dash, A2 dash, and A3 dash. A1 dash, why not dash? This is 1 in the superscript. We are using 1. This 1 means it is inverted position with respect to position 1. Okay, with respect to position 1, we have inverted. Okay, now see, the solution is not a good solution, but let's finalize the solution. So now we will, what we will do, we have to join these points A1 and A2, then A2 and A3. Okay, then we will draw the perpendicular bisectors. So next is we have to draw perpendicular bisectors. To draw the perpendicular bisectors, the method I follow, I draw a circle here, another circle here, then a circle there, another circle. Okay. Now we will have the perpendicular bisectors. So the perpendicular bisector for A2, A3, the perpendicular bisector is this one. Agree? Okay.
Yes, sir.
Yes, sir.
And A1, A2, this is the perpendicular bisector. Same. I'm just removing this many circles. Okay, so now you have perpendicular bisectors of these points, and where these two things will intersect, and that will be the point B, okay, on the follower. So to do that, let us extend this line. Extend तो नहीं कर सकते हैं, but then manually we can do it. Okay, and for the other point, we take from this point. अभी भी intersect नहीं किया. Okay. Let's select this line and I'll stretch this line. Now it's fine, right? And they intersect at this point. So this point we'll call, this point is point B. This intersection point is actually point B. Now can we shift some of the writings little bit so that I'm removing. I'll remove this. Okay, and let's copy these fellows. Okay. Let's see it. Okay, now let's see. So this is the intersection point. This intersection point is the other point of which is so how our purpose will be fulfilled. Now you see that this let us write down everything here. This point is O4, this point is O2, and we have, with respect to position 1, we have drawn everything. That means this A1. So the mechanism we have now, and this is actually B1. So the mechanism is O2, A1, or you can say 1 dash B1 O4. This is the mechanism. Okay, so let us just copy. This is our figure 1 from where we have started. This is figure 2 where we did all the inverted positions, but we want to draw the mechanism fresh. So I am just copying the points, all the hinge points. This is link 1, okay, fine. Link 1, hinge point, link 2, O4, and P. Okay, you can also take this one of the lines. So I'm drawing it here. Now, as you see, this drawing is very simple. Now, using your trace paper, you can do it simply. You can do it, no issue. Just see that this is our point O2, O4, A, and this is B. Now I'm saying that let's join A and B. So if you join A and B from this point to this point, okay. Now what we can do, you can take this. Okay, let's extend this link to make it much acceptable. So I have now extended. Or see, you can do this, or you can have a link like this. Any kind of shape you can give. See, this is the follower. I can, I mean, I can just start from here and extend the follower and make the follower like this. Okay, this is the follower we have. All right. Now you see any line, this line you take on the follower, it will give you that coordinated motion. In this direction, the coordinated motions are from theta 4 from 1 to 2, and then theta 4 from uh, and then you have theta 4 from 2 to 3. All the motions you will have when you have here the motion from theta 2 1 to 2, and then you have theta 2 2 to 3. This is the mechanism. Do you got it? How we arrived to this solution? Any question?
Yes, sir.
Is it fine?
Sir, can we decide the size of follower on our own?
Yeah, that's what we have. Uh, okay, you want to say that you want to first decide the size of the follower, then you want to have the size of the crank, right?
No, like now B point was not lying on follower, so you extended the
Yes,
shape of
yes,
the follower.
yes. You can change the shape of the follower. But if you just see here the motion of the follower with crank is related by this only. I have just yeah, I can have a I can have a follower like this. No issue. ठीक है?
Yes, sir. Okay, sir.
Only the linear distance, just the you see the distance between O to O4 and B. I have not changed during this. ठीक है ना? So this way you can change. Also related to your question, as I have already discussed also, that you can also change the problem can be like this. I mean, one can ask you that the follower motion and crank motion are coordinated like this. The these two pairs are given. But suppose somebody asks you that the position B on the follower is known to us. You find out for position A on the crank. Can you do that?
Yes, sir.
Yes,
Okay,
sir. Okay.
Yes,
just
sir.
Yeah.
yeah, inverted motion of the follower with respect to crank. Okay, that's what we have to do. Fine. Any question from this?
Sir, sir,
Question है कोई? हाँ पूछो.
सर O2 O4 लिंक का लेंथ फिक्स है क्या?
No, that that is not fixed. Here we have assumed some length. There it might be given. Okay. ठीक है. The problem it depends on requirement of the problem. You know, sometimes we have constraint of space. You want to use a mechanism, there is a space constraint. So that using that also the hinge points O2 and O4 in a machine or in some system, you have to use the mechanism, and the support points are sometimes available that you have to use these support points only. That is a constant. So from that point of view, this O2 and O4 are fixed from the requirement. Okay. In another case, if you have the freedom of choice, then you can choose O2 and O4. Okay.
Yes, sir.
Okay. So this is the discussion on our function generation. Now we will move to the next topic. It's called data center problems. Okay. So today I don't know whether I can complete the. At least I will try to finish the problem statement. What is a data center problem? Yes. This is our lecture number 9. We are part B. We are discussing now the data center problem. In those cases, the other three types of problem, there we have not discussed about the extreme positions. But in this case, we will discuss the design will be based on the extreme positions of the links. Okay. So first we will discuss synthesis of a slider crank mechanism. Okay. Let me give you the problem. A slider crank mechanism is to be synthesized for values of quick return ratio and slider stroke. Okay, so what is given? Quick return ratio and slider stroke. These two things are given. You can also sometimes this offset of a slider crank mechanism that can be given, or you can assume that slider crank, the offset in a slider crank mechanism. This can be specified depending on the space constraint. Sometimes the offset may be specified or it may not be specified. In that case, you have to assume that this. So the two, let us now draw the two extreme positions which are called dead centers. Two extreme positions of a slider crank mechanism with offset. Suppose we start our drawing from here. Suppose this is the hinge point. Okay. This is the hinge point, and crank is, let's say crank is moving on this circle. And one of the extreme position before we do that, let us draw a line. Suppose this is the line on which we want the motion of the slider. Okay, on this line we want the motion of the slider, and since this the slider stroke is given, you can first choose the two extreme positions of the slider based on the stroke length. Okay. For example, suppose you have chosen this is the first position or one of the extreme position of the slider. Okay. And the other extreme position of the slider, suppose somewhere here it is. Okay. Although when I am drawing this is an example, so that means the position will not be, the lengths will not be the exact same length. Just for example, what is the state center problem? We are doing this. Maybe I can. Okay, first let us connect these 2 points. This is one of the extreme position. This is one of the extreme position. Obviously, you have the crank and the slider is connected, crank and the coupler is connected at this point. Okay, this is the coupling point, connecting point between the crank and the coupler. Okay, on the other hand, if we want to keep it correctly, so let me just draw a line from this point to this point, make it green, and now I want to shift this from this point, and we want to rotate. So let's rotate it a little bit. Okay, again rotate it. Little bit. Okay, that I can solve another way. First, this whole thing, if we shift little bit from this position to this position, Okay, now it's perfect. So I now draw a circle. Okay, so this is a case where you see we have drawn two extreme positions. This is one of the extreme position and this is another extreme position. The let me know. So from this point to this point, we have this distance is the stroke length S12. Okay, that is given to us. And what is the quick return ratio? What is the quick return ratio? If you know this angle, okay, that also I can do. So this angle, if suppose this angle is theta to 1, 2, that means when the crank is rotated from this point to this point, this has this motion, the backward motion, and the forward motion is from this point to this point. This motion is for this angle. So actually the quick return ratio R is defined by this theta to 1 to divided by 2 pi minus theta to 1 to. Okay, this is the quick return ratio, and if this value of R is given, you can find out from this, you can find out theta to 1 to, I'm writing it from just algebra, you can find out. Okay, so this angle theta to 1 2 you can find out. So what will be given in the problem? In the problem it will be given the what is this S12 value and what is this R. These two things will be given, and you can assume the you can assume this distance from this point to this point. This distance you can assume. This distance is called offset E. This distance you can assume or it may be given. So these three information or two informations will be given. You have to find out what is this mechanism. So to find out the mechanism, obviously you need to find out what is the length of the coupler and length of the crank. Also you need to define what is your offset. If it is given, then just these two lengths we have to find out, and if it is not given, then you have to assume some offset and you'll get this. So this is the problem we have to solve. In our next class, we will graphically solve this problem. Okay. If you have any doubt, you can ask me. The class is over. You can log out, or if you have doubts, you can ask me.
सर हम लोग को केवल ग्राफिकल पढ़ना है कि एनालिटिकल भी पढ़ना है बाद में?
हाँ, क्या बोल रहे हो?
सर जो मेथड्स बता रहे हैं इसका एनालिटिकल मेथड भी पढ़ना है कि केवल ग्राफिकल ही पढ़ना है हम लोग को?
No, for these cases we have only graphical methods. Okay.
ओके सर.
Anything else?
सर आपने जिस बुक के बारे में कहा था सर, वो सॉफ्ट कॉपी तो अवेलेबल नहीं है किसी
नहीं है,
इंटरनेट पे सर?
सॉफ्ट कॉपी अवेलेबल नहीं है. You have to buy the hard copy. This book is a very famous book and most of the IITs follow this book. ठीक है.
सर क्वेश्चन प्रैक्टिस के लिए क्या सर आप इसे क्वेश्चन हम लोग को पीडीएफ फॉर्म में भेज सकते हैं?
Okay, I can see one of you can buy this book. This is a very good book, only 300, 400 maybe cost. And one of you can buy and take pictures, can send. Okay, otherwise, I think you go to my web page in the institute website. There are some problem set for dynamics of machinery given. Okay, you can follow those problem sets. If I am
Okay,
not wrong, it is there, which I have prepared 2 years ago. Okay, same. Let me check whether they are there or not. And this is, you go to my web page and then teaching and not teaching, course handouts. In course handouts it is there, course handouts and assignment. If you go to that page, so the practice problem sets are given. Okay, let me show you. Can you see this? I hope you can see this. Hello?
yes sir.
You just
Yes,
go
yes,
to
sir.
this. You just go to the web page and you will get all these problem sets. They will help you. Okay.
Okay sir.
Fine. So tomorrow no class is there, and we will have class on next Monday. Tomorrow the lab class will be conducted by TS. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.